Hello class, welcome to this video on AP Statistics, Lesson 4.1 homework. So Chapter 4, Lesson 1 is what we went over in class, and we're going to look at the homework problems. Now keep in mind the homework problems do say 4.1 and 4.2, but they're really both from 4.1. So let's go ahead and get started. So a local college has a total of 11,000 students planning to attend an upcoming school year, which includes 3,000 incoming freshmen. The athletic director wants to get an estimate of what percent of the incoming freshmen want to purchase tickets for the football games. She takes a random sample of 4,400 freshmen and contacts them by email. Identify the sample and population. So this is what we were talking about before, sample versus population. The population in this case is the 3,000 incoming freshmen. And then from those 3,000 freshmen, we took a random sample of 400, right? So identify the sample are the 400 freshmen randomly selected. The population are the 3,000 incoming freshmen. Okay, so number 2, a census is a census is a survey in which every item or subject in the population is selected. Every 10 years, the U.S. Census Bureau completes a census to count every resident in the United States. Identify at least 2 challenges with conducting a census. So again, a census is when every single person is selected, right? So you're surveying the entire population. So here we're just saying, okay, well, if you're trying to survey every single person, what kind of challenges are there? Well, first off, it requires a lot of people to be out there surveying serving everybody, basically. It also costs money, right? A lot of money. So there's a couple of challenges right there. Is the workforce as well as the expense. Also, trying to time, right? So time is a big issue. Trying to make sure that after the 10 years that you do this in a expedient manner. Right, so time is a challenge. So the time it takes to survey everyone in the population and the resources, including money, amount of workers, etc. All right, so those are some challenges with doing a census, and this is why in statistics we tend to go with, actually doing a sample, right, and so planning our sample so that we can just get less people in our sample and use that to infer results from the population. All right, so number 3, a city planner is researching a proposal for a new community building project that would require destruction of protected wetlands. The city planner creates a poll on social media to find out how people in the city feel about the proposal. 93% of the people who responded were against moving forward with the community building project. All right, so it says the city planner creates a poll to find out how the people feel, and then 93% of the people who responded were against moving forward. Okay, so 93% of the people were against moving forward with the community building project. What type of sampling method was used, and explain? Okay, so here they created a poll on social media, right? And then people had to actually go in and respond, right, on social media and respond. So this is a voluntary sample, right? Voluntary response. As long as somebody self-selects to go and participate in a survey, we call that voluntary response. Okay, and then it says explain. Individuals self-selected or volunteered to be part of the survey. All right. Okay, so part B, explain how the sampling method might lead to bias. Okay, so let's do that in here. Let's do that in part B. So how can this lead to bias? Well, people, or let's say the people. So in this example, we're looking at a community building project. They're against moving forward with the community building project, right? But it says here that the community building project will require destruction of protected wetlands. So who are the people that are likely to respond? Well, the people that are likely to respond are those that feel strongly, about the environment. So they feel strongly about this issue, about the destruction of the protected wetlands. So they're going to want to move against this, right, proposal. So the people who volunteered in the poll are likely to feel strongly about the environment. All right, which so say are more likely. I guess I can say also. Okay, let's talk about the people. So those who do not feel strongly about the environment, about protecting the environment, are less likely to participate or to vote in the poll. Okay, and because of that, you're eliminating some people are less likely to do it, and therefore you're going to result in bias. Do you think the 93% is higher or lower than the true percentage of people that are against a community building project? Well, if we're talking about this bias right here that we talked about in part B, well, then it's likely to be higher, right? So the 93% is likely to be higher due to the people feeling strongly about the environment. So in other words, most of these people feel strongly about the environment, and so they're more likely to vote, and therefore that inflates the percentage. Okay, so number 4, a group of entrepreneurs is thinking about opening a new business that provides remote workers with a shared workspace and good internet access. As part of their research, they interview people at several local coffee shops. Based on the interviews, they conclude that 85% of people in the city are remote workers. All right, so what type of sampling method was used here? Well, if you look at it, so they interview people at several local coffee shops, okay? And so first off, look at the word local. They contacted people in their area, okay? So if you're contacting people in your area, that is a convenient sample. They didn't use any randomization for their process, okay? So for part A, this is a convenience sample, since they selected individuals that were easy to reach and did not use randomization. All right. So, and that is going to lead to bias, right? So we want to explain how that leads to bias, right? So for part B, how might that lead to bias? Well, so if you're talking about opening a new business that provides remote workers with a shared space and good internet access, right? Well, and then you go ahead and interview people at local coffee shops. Well, think about it. Coffee shops usually they have good internet access. They have lots of space for people to work. Maybe order coffee and work. So it's probably going to be likely to be to have more people that are remote workers or people that need to use the internet, right? So than people who are not at the coffee shops. So there might be some kind of variable involved there. All right. So we're going to say that the coffee shops would tend to have people that may be remote workers than those not at coffee shops. Due to good internet access, or due to good internet access and space. And yeah, access and space. All right, so again, introducing randomization helps us offset this issue by choosing other shops, other places, besides just the coffee shops, which tend to have good internet access, which tend to be places where people go to just to either work or to access the internet, right? And so that, we want to keep those in mind. So for part C, do you think the 85% claim is higher or lower than the true percentage of people in the city who are remote workers? Well, they went to the coffee shops and they found 85% of the city are remote workers. Well, what we said earlier is that those coffee shops are likely to have more remote workers, and that's likely why that percentage is inflated, right? So in this case, it's likely to be higher. Due to surveying people at coffee shops, which tend to have good internet access and space available to work. All right. That takes care of number 4. So let's look at number 5. So Apple uses a Net Promoter Score, NPS, to measure customer experience. The NPS measures the likelihood that a customer would recommend the company to someone else. Suppose an Apple Store manager has a list of all 91 customers for one day at the store. She wants to take a random sample of 10 of these customers to estimate the Net Promoter Score for that day. Describe a method for taking a simple random sample using a random number generator. All right, so being able to describe the method is very important, especially for the free response questions, right? So you have to be able to describe in detail what you're going to do, whether you're doing random number generator, where you're doing a raffle with names in a hat, whatever the case may be. So we're going to make sure we specify exactly how to do this. So for part A, in order to do it, since we're going to do a random number generator, this is what we did in class, right? Is you label, right? Then you describe the random number generator. So you're going to generate how many numbers between what and what. No repeats, right? So, numbers that don't repeat. And then you're going to go out and the person selected corresponds to those numbers that are generated, right? So that's a general template. So in this case, we're going to label each customer with a number. So I'm going to put the label part. between 1 and, so now here we want 91 people. So we're going to, the first person, one person's going to have number 1 all the way to 91. With no repeats. Okay, so you know, obviously you can't have any repeat, or oops, I got ahead of myself. I was talking about the random number generator. So we got label each customer with a number between 1 and 91. Then we're going to use a random number generator to select numbers between 1 and 91 with no repeats. So let me put this as step 1. Step 2, use random number generator to generate 10. Now we want 10 of the customers, right? So 10 different, so there's a key there, 10 different numbers between 1 and 91. And then contact each customer corresponding to the numbers, right? To the numbers generated. All right, so there's a very specific process. You have to include the word different, or say 10 numbers between 1 and 91, no repetition, right? Or no repeats, or whatever. And then, you know, you need to include, label each number between what and what, right? You gotta be very specific. All right, so let's look at part B. Let's compare that to part B. Now, part B, you're doing this in a hat, right? So using names in a hat. So you're gonna have slips of paper. You're gonna write the customers' names, right? You're gonna write the numbers of the customer. So like write down their full name, whatever, Sally, Joe. Put them on equal size slips of paper, and then you're gonna mix them up in a hat, right? And then select 10 random slips, right? So write each customer's name, full name, on equal sized pieces of paper. Now the equal size means is a detail, because if the papers are a different size, you might be more likely to pick one than the other, right? So we want to make sure everybody has the same chance of being selected. So equal size slips of paper, and let me use the word slips of paper. Okay, put the names in a hat and mix them well. You have to include that part, mixing them. You can't just put the names in hat and then choose. You have to mix them up so that it's, everybody is it's all scrambled. Now you're going to randomly select. I'm going to include this with this process. Randomly select 10 slips of paper, or 10 slips from the hat. Now this is key. Without replacing them. You do not want to take a slip, record the name, and put it back. You want to select them without replacements. You don't want to put them back in the hat. Contact each customer. Whose names, each customer whose name is on the slip of paper selected. All right, so there's a well-detailed 3-step procedure for describing it, okay? So, depending on the method, if you're doing technology, label the customers with numbers. If you're doing paper, write each person's name on equal size piece of papers, so on and so forth. There's a method to this. All right, so number 6, we're going to describe another method. So one method for selecting random sample is using a table of random digits. So the table includes a series of random digits, 0 to 9, arranged in rows of columns like this. And we got a table of random digits that you got in class, right? Suppose the manager at the Apple Store wants to select a random sample of 10 customers from the 91 customers for a day. Okay. So describe how to select this simple random sample using the given table of random numbers. All right, so let's do that for part A. So first off, because we're selecting 10 customers, we want to make sure that, and there's 91 customers in total, right? So 91 is our customers that we want to select from. So we're going to label each customer from 1 to 91. However, because this table of random numbers has, just a bunch of numbers there, we're going to break this up into 2-digit numbers, okay? So here, that's a 2-digit number, that's a 2-digit number, and so on and so forth, right? So that's what we're gonna do. Okay, so let me write that out so you can kind of see. So we got 59, we got 23, then we got 54, 85, 06, 93, 43, we got 15. Then we got 07, we got 54, we got 38, 86. Again, this is all from that table. We got 36 there, 58, 32, 36, 93, 43, 26, and 42. All right, so those are all listed 2-digit numbers from the table, from left to right. For part A, so when we describe this, we're going to label each customer from 01 to 91. We're going to want to ignore the numbers 0, 0. We're going to want to ignore 92, 93, 94, all the way to 99, because we only have 91 customers for that day. So those are things that we want to keep in mind. Okay, so label each customer with a 2-digit number, 01 to 91. Move left to right in the table of table of random digits or random numbers, 2 digits at a time. All right, 2 digits at a time. And then we want to ignore 0, 0, 92, all the way to 99. And we want to basically ignore repeats. So we don't want to repeat, okay? So select 10 unique numbers. All right. Select, I guess we'd say the first 10 unique numbers, so no repeats. Okay. All right. And then the last part is talking about contacting the people, right? So whoever is selected, whoever corresponds to that number, they're the one that's selected. Okay. So contact each customer that corresponds to numbers selected. Okay, there's our process. So that's what we're going to do. So we got the customers 01 to 91. And then we're going to go ahead and do that process. So move left to right on this table using these two rows. Ignore 0, 0, ignore 92, 93, 99, so on and so forth. Okay, so far we got 59, that's a customer. 23, that's one of our customers we can choose. 54, that's good. 85, that's good. 06, that's a customer as well. 93, we ignore that because that's 93, that's 92 to 99. 43, that's fine. 15, that's fine. 07, that's okay. 54, that's a repeat, right? So no. 38, that's fine. There's no repeats there. And then 86, yeah. Okay, so now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the first 10 unique numbers, right? So we're going to, which customers will be selected? We're going to select customers 59, 23, 54, 85, 06, 43, 15, 07, 38, and 86. All right, those are our 10 customers. Okay, so that's how we randomly select them. Okay, so let's look at number 7. Again, if you, I don't think you have this on your homework assignment, but I do want to go over it just so you have extra examples to look at. So as part of a study by a certain medical association, hospital and admins and doctors will be asked about new standards of care for elderly patients. From the 270,000 members, a random sample of 400 admins and 800 doctors was selected. Of the 1,200 members selected, 1,100 members indicated they were familiar with the new standards. What are the population in the sample? Okay, so population and sample, we guys choose the choice. All right, population is the 1,200 members who were selected, and the sample is the 1,100 members who indicated they were aware of the new standards. Okay, so let's first identify what the population is. So based off of this information, okay? So hospital administrators and doctors will be asked, right? So that's who you're asking. So it says 270,000 members. Those are the 270,000 hospital administrators and doctors. That's your population, okay? So out of those people, then you take a sample of 400 admin and 800 doctors. That's your sample. So we got 1,200 participants. Okay, so it's not A, right? It says the population is 1,200 members. No, that's the sample, right? Of that were selected. Part B, the population is the 1,200 members who were selected. Okay, so that part we said, cannot be true. So it cannot be B, right? We said the population is the 270,000 members, so we know it's not that. The population is the 270,000 members. So that part looks good. The sample is whether or not each member was aware of the new standards. No. The sample are the 1,200 people who were selected, right? And then they just said that 1,100 were familiar with it. So it's 1,200. So this is not correct. Okay, populations of 270,000 members, yes. The sample is the 1,200 who were selected, yes. That's what we're looking for. All right, so the answer is D. All right, number 8. In which of the following situations would it be most difficult to use a census? All right, so to determine what proportion of post office boxes are available for renting in the local post office. So this one, the population is all of the post office boxes in that local post office, right? And that's not going to be terribly difficult. So that's not too bad. You're just saying the proportion of all the boxes that are available for renting. That's not hard to do. So that's not difficult. You want to look for the most difficult situation. To determine what proportion of students in a high school participate in athletics. That's not terribly difficult. You just wanted the students in one high school. It's not like you're doing multiple high schools in an area, right? So that's not too difficult, especially if you're already a student in the high school and you're surveying students in your school. So that's not terribly difficult, but let's look at the next one just in case. To determine what proportion of registered voters actually voted in the most recent school board election. Okay, so again, that's a little bit on the difficult side, but remember, it's not you're looking at what proportion of registered voters. So it's not like you're looking at every single person. You're just looking at those who are registered, which will still be a lot, right? So that could prove to It says what proportion of registered voters who actually voted. So proportion of registered voters that may be proved difficult, but let's see. To determine what proportion of licensed drivers in a small town own electric vehicles. Okay, so in a small town, just in a small area, that might not be as bad. To determine what proportion of deer in a state. Okay, so now you're starting to see an example. Okay, so first off, you're in a state. So you're looking at, for example, the entire state of Florida or the entire state of New York, the entire whatever state. So that already is a big area. Not only that, you're looking at animals in an area. So that's more difficult to do. So I would say probably the most difficult would be E for this one. Definitely, you're surveying specific animals in an entire state. All right, so let's go ahead and take a look at Lesson 4.1 Part 2, which again is called 4.2, but I said it was Part 2. A local Amazon distribution center delivers products to 3 different states: Illinois, Michigan, and Ohio. All right, there were 14,500 purchases delivered from this distribution center on one day. Amazon wants to send a customer service survey to a sample of 100 customers who got one of these deliveries. All right, describe a method for selecting a simple random sample. All right, so we got Part A. All right, so we want to select a simple random sample. So this is like what we did in Part 1, right? Describing that. There are 14,500 purchases, right? So we want to look at those. So we're going to label each customer or whatever with a number from 1 to 14,500. All right. So each person gets a unique number from that list, from those numbers, and then we're going to use a random number generator. So if we want to select a simple random sample, let's just use a random number generator. Okay. So label each customer with a unique number, meaning it's not repeated, right? Unique number from 1 to 14,500. Now we're going to use a random number generator. How many people do we want? It says you want to send a customer service survey to a sample of 100 customers. To generate 10 numbers. Now 10 different numbers, right? So no repeats. Or 100, I'm sorry, I said 10. 100 numbers. 100 unique numbers. No repeats. Between 1 and 14,500. All right, and then we want, when we choose those 10 or 100, then we're gonna go ahead and so select those customers corresponding to the numbers that were generated, right? So send the surveys. So send surveys to customers corresponding to numbers generated. All right, that takes care of Part A. Now let's look at Part B. It says, is it possible that there are no customers from Michigan in the simple random sample of 100 customers? Explain. Okay, so that's a good question. So remember, the thing about the simple random sample is that it's better to do a simple random sample because there's a good chance that every single person is selected. However, there's no guarantee that every single type of person is selected. So in this case, there's no guarantee that will represent the 3 states, right? And so that's an issue with the simple random sample. And so to alleviate that issue, what we can do is we can do a stratified random sample and look at the different states, right? And then select people from each state, right? And then that will ensure that we have persons from each state represented in our sample, right? So this is the problem with simple random sample, right? Is that if you want the three different states to be represented, then you have to use a different method. Okay, so that's what we're going to do. So here, it is possible. So we're going to say yes, it is possible that customers from Michigan are not selected because a simple random sample does not guarantee that specific individuals are selected. Okay, so a simple random sample does not guarantee that different types of individuals or specific individuals are selected. It just guarantees that everybody has an equal chance of being selected, but there's no specific guarantee about specific groups, right? So the best way to do this, it says, how could we ensure that the customers from all three states are represented? That's where we have to draw from each state. Okay, so we're going to do a stratified sample here. Okay, so to use stratified random sampling, stratified random sampling. So we're going to take the three states, use the three states as your strata, then take an SRS, a simple random sample, from each group, from each state, from each stratum / state. Okay, so that's how we can ensure that we have representation from each state. All right. Okay, so high school principal for a small high school of 400 students wants to survey students about a new proposed requirement that athletes must maintain a perfect school attendance in order to continue to participate in sports. She decides to select a stratified random sample of 40 students. Would it be better to stratify by grade level or by whether or not students are athletes? Explain. Okay, so so in this case, they're saying, well, the proposed requirement is that the athletes must maintain a perfect school attendance to continue to participate in sports. So obviously, this involves athletes, right? And so it would probably be better to just break it up by whether or not they're athletes. So you have the athletes voting on it, being surveyed, and then you have the non-athletes being surveyed on it. That way, you can see a distinct difference between the strata, and then you can also have representation from both groups because you're selecting from both groups to see, to have better representation. Okay, so so we're going to select. Would it be better to stratify? So to stratify by whether or not they are athletes, since what they think about the policy is likely to be affected by whether or not they are athletes. Okay, so there's part A, and then part B. Describe the process for selecting the stratified random sample. All right, so we're going to talk about that process. So we're gonna stratify by whether or not they're athletes. So we're gonna split them up: athletes, non-athletes. Then from the athletes, we're gonna do a simple random sample, and select X amount of people. From the group of non-athletes, again, do a simple random sample. And then combine them to get your sample, all right? So here we go. So we got, we're going to break the population of students into two groups. Athletes and non-athletes. Select an SRS, a simple random sample, from each group. Combine all selected students for the stratified random sample. So for example, if I did a simple random sample of 20 from each group, then that's a total of 40 for my sample. All right, so there's that explanation. All right, so now let's look at number 3. A large fast food restaurant has a total of 150 employees. There are 120 employees paid hourly and 30 employees on management salary. The owner of the restaurant wants to select a sample of 20 employees to attend a team meeting. Describe one potential issue with selecting a simple random sample of 20 employees. Okay, so while doing a simple random sample allows for randomness, remember that randomness does not guarantee that we have the best representation. So there's a good chance that when we survey 20 employees, that they're actually all hourly employees or very few management employees. Okay, so we want to make sure that we have equal representation, or we want to make sure that we have better representation of everybody. And so there's a good chance that we're not going to have any salary employees by doing this, or vice versa. There's a good chance that we may not have any hourly employees, right, when we do our sample. So in fact, we have 120 employees that are paid hourly. So if you think about it, those 120 employees, you have a greater chance of selecting those 120 employees when you think about the number of employees that get paid hourly. And so what you want to do is you want to break them into groups, right? So all right, so here it's possible that the 20 employees selected would be all hourly or all salary. Okay, so there's a potential problem. And so for part B, what we're going to do is we're going to say, well, it says, suppose the owner decides to take a stratified random sample. So he does 10 from each, right? 10 hourly and 10 management salary. Are the employees within each group homogeneous or heterogeneous? And explain. So, in that case, well, that's going to be perfectly fine, right? If you select 10 employees from the hourly, they're all homogeneous. They're all paid hourly. You select 10 from management, they're all homogeneous. They're all hourly, or they're all salary. Okay, so that's fine. No issues there. So for part B, I'm going to say it's homogeneous. Homogeneous since all employees in each group are similar in how they are paid. Hourly versus salary. Okay. All right, so let's look at part C. The owner realizes that using equal-sized groups for the hourly wage employees and management salary employees is not representative of all employees. What sample sizes should be used for each group in order for the stratified random sample to be representative of all employees? And that's a good question because there's 120 hourly employees and only 30 salary employees. So if I choose the same amount from each, so if let's say I choose 10 from each, then I'm 10 out of 120. I chose 10 out of 120 hourly employees, and then I chose 10 out of 30 management employees. 10 out of 30, that's like 33% of those employees. 10 out of 120, that's less than 10%. And so these are things you want to keep in mind in order to make them, the same representation here. And so in this case, since we want 20 employees, right? So let me just put we want to choose 20 people, right? 20 people that we want to choose, and then that's the total number of people in our sample. And now it says there's for the first group the hourly employees, there are 120 out of 150 employees. 120 were paid hourly. Okay. And then, so this is the number of people that we would expect to select from the hourly. Now, on the other hand, we got 20 people that we want to select, and we got 30 employees on salary out of 150. Now, 30 out of 150, that's 1/5, right? So 1/5 of the people were salary. So 1/5, that's 4. Okay, so we want to select 4 salary employees. And then here, this is 4/5. Okay, so 4/5, that's going to be 16 employees. So 16 hourly employees. This ensures equal representation among both groups. All right, so that's number 3. Number 4, the Bureau of Labor Statistics uses a complex sampling method to estimate the overall unemployment rate every month. The sampling method has low bias and low variability for estimating the employment rate. What is meant by low bias? All right, so this method that they're using, this complex sampling method, when they're saying it's low bias, it means that their method, when we use that method, their method allows for estimates to be, to not consistently over or underestimate the true unemployment, sorry. Meaning, so if you use their method, you're going to come up with an estimate for your sample that is not necessarily going to consistently overestimate, or it's not going to necessarily consistently underestimate the unemployment rate. Okay, so it's going to be basically pretty much close to being on target, right? So there's not going to be that bias there. Okay, so there's a difference between low bias and low variability. Okay, so again, low bias is so if you have high bias, that means you're consistently overestimating or you're consistently underestimating. Low variability, and obviously if you got low bias, that means you're not doing those things, right? So you're basically either overestimating, underestimating, or on target. You're just kind of, above or below, but you're not consistently making a certain mistake. Low variability, on the other hand, is you're very close to target. You're close to being on target consistently. So their method for low variability allows for the unemployment rate to be consistently close to the actual value. Okay, so those are two important concepts. So for number 5, for a recent season of Major League Baseball, Miguel wants to estimate the average number of total runs scored per game. He plans to take an SRS of 20 games and use the mean of the sample as the estimate. Okay, so he's using the mean, the average. The simulation results below display 10 sample means from 10 separate simple random samples of 20 games each. Okay, so basically it's saying that he took each sample is 20 games. So he took 20 games and then he took the average of those of the results, right, of those 20 games, and then that represents one dot, and he did this 10 times, so that's why he's got 10 results. Okay, so that's what that's saying. Based on the dot plot, estimate the true mean number of runs scored per game. Explain your reasoning. Okay, so this is called a sampling distribution of sample means, all right? Because we took a sample, and each dot that we selected is a sample of 20 games that we took the sample mean of, right? So we took the average of it and then we plotted it. So that's a sample mean. So that's a sampling distribution of sample means. Now, when you get the averages plotted like this, the true mean number is the center of that distribution. Okay, so when you go to the center of that distribution, that'll tell you what the true number is going to be. Okay, so we're going to go ahead and find the center of this distribution. So the center of this distribution is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, so this is like the center is right here, right? So this is the center of the distribution, which is 8.3. Okay, so we're going to say 8.3. So it's approximately 8.3 runs at the center of the distribution. So it's located at the center, so we would expect that that's the true mean number. Since we took a simple random sample, we overestimated it as well as underestimated it, right? And because there is low bias, that means that we didn't consistently overestimate or consistently underestimate, and so we could take the sort of average of our results, and that kind of gives us the true mean. All right, so for part B, Miguel realized the American League teams tended to score more runs than the National League teams during the season, possibly due to the use of designated hitters. He decides to combine separate simple random samples, one from each league, to form a stratified random sample. Draw a dot plot that could represent the distribution of estimates for 10 simulations using a stratified random sample. Okay, so your dot plot is going to vary. It doesn't have to be exactly what I have here, but the main idea is that what he did is, since he said that he's breaking it down by the league, well, since he's using stratified random sampling, then what that's going to do is that's going to decrease. That's going to be better than doing the simple random sample, as long as he breaks it up into strata that actually matters, right? And so in this case, if he does a simple stratified random sample, it's going to reduce the variability, and it's also going. It's still going to have the same center as the simple random sample, so the middle of your dot plot should still be 8.3. However, it should have less variability. So we could draw a dot plot, and here's just an example. 8.2, 8.4, 8.6, 8.8, 9.0. But now we're going to draw a dot plot with reduced variability. And so it's going to be more clumped together. We might have maybe something like that. And then that's already 2, 4, 6. That's already 7 dots. So let's just do maybe a couple. 8, 9, and 10. Okay, so here we got reduced variability. We can see it varies from 7.4 to 8.8 as opposed to 7.6 to 8.8 as opposed to 7.4 to 9 point whatever. So there's reduced variability and there's more clumping, and the center is still around 8.3. Okay. All right, so that's what you want to look for. All right, so we're going to finish this up. Which of the following is not true for a stratified random sample? An SRS is taken from each stratum. That is true, so we're not going to choose that. Individuals within each stratum are homogeneous. That is true, so we're not going to select that. Every possible sample of size n from the population has an equal chance of being selected. Okay, and that is not true. Okay, so not every possible sample size has an equal chance of being selected. Remember that these results are not guaranteed that a certain person will be selected or whatever, and that every single possible sample will have an equal chance. So let's look at part D. Individuals cannot belong to multiple strata. That's actually true. An individual has to only belong in one strata, can't belong to multiple. Strata are clearly defined prior to sampling. Yes, you have to define the strata prior to doing a stratified random sample. So you can eliminate the other ones, and this is like the only one that doesn't seem to be remotely true. Number 7, a research company is interested in estimating the mean number of minutes people spend on social media apps. A random sample will be selected from each of 4 strata by age group. Selected individuals will be asked the number of minutes they spend on social media apps on a typical day. Why is stratification used? Okay, so what they're saying is that they're thinking that the age group affects their response to the question, how many social media apps they use, right? They're thinking that age has an effect on it, and so they're breaking it up into strata that will influence their response. Okay, so that's important. To remove bias when estimating the proportion. Not necessarily, right? So it's not to remove bias. The idea is that you want to break them up by response so that you can get a better representation of each age group to see what their overall what their response is going to be like. But you do know that certain age groups are going to influence it in a certain way, or there's a relationship there. To remove bias when estimating the mean time spent on social media apps. Okay, so this one's when estimating the proportion of individuals, when estimating the mean time. Again, the same idea. Those are not. That's not why stratification is used. To reduce bias when estimating the mean time spent on social media apps. Again, not to remove bias or reduce bias. That's not the intent of it. The intent of stratification is to reduce the variability, because remember, a simple random sample will also remove bias, right? It's not the reason why stratification is used, because simple random sample removes bias or reduces bias, right? What we want is for us to decrease the variability of the mean time. And this is what we're looking for. All right, guys, that's going to do it for the video. I hope you learned something, and as usual, I'll see you in the next one.